Good morning. Coffee still hot. Kind of feels right. Hey. Right, before I do anything, I realized something. Not this one. I should probably close this folder. Where's Handmade? Yeah. Don't worry, I didn't leak anything. It's my own project. But what am I doing? I should get some more coffee first. Okay. Yeah. Oh fuck, but I removed it. Maybe I can undo it. Go back. No. I'll have to go all the way back. I have to take my word for it. Or you can not watch the last video. Right, anywho. Oh, woo. I realized as I was writing, what was I writing? Yeah. I was trying to think through things as to like why I need some more coffee. As to what the problem was. And the problem was down to peace. Well, one of the problems was, oh, okay, two problems. Problem reasons for switching from Alpha to PuliseAudio. Well, the first one was the first one. Okay, when in map mode, which is the same as writing directly to memory in Handmade Hero, the audio device is busy because of PuliseAudio, and it doesn't allow mmap access. And yeah, well, there was something else. Okay, jeez, I don't think this makes any sense. Apologies, I just woke up and it's a bit too early. PuliseAudio and yeah, when picking the hardware for the audio, which is 00. What's it called? Was it Elsa? Not Elsa. AL audio. -l. I can't remember the command. Anyway, there's a way to check it, and when I pick hardware 00, it's busy because it's locked in by PuliseAudio. And if I using simple write I can play the audio, but PuliseAudio tries to clear memory. Yeah. I can use right eye, but after the audio plays, PuliseAudio tries to clear memory. And since it's a different process, not invoked by me, or did I invoke it? No. Yeah, I can't clear memory. Or maybe because I didn't use, what's it called? C.malloc or something. Either ways, doesn't allow me to clear memory, but I don't want the memory cleared because I want to write to it over and over. Coffee. So I realized in both these situations, PuliseAudio already is running the audio. So why don't I just use PuliseAudio? Well, that's it. Those are the reasons. I'm still waking up. How is it? Right, so don't know anything about PuliseAudio, but I have seen a simple API, which is always a good news. If I've learned anything from X11, it's that there's a complex way of doing something, and there's a simple way of doing something. Pick the simple one. Here's the default server, application name, default device. Once the data Once the connection is established to the server, data can start flowing. Using the connection is very similar to normal read-write system calls. The main difference is they're called PA simple read. Hey Jonathan. I don't know yet. I mean, it's taken me 2 weeks to get window and audio, which is not working yet. So I don't know yet. The problem for later. Cool. PA simple read and simple write. These operations always block. Simple get latency will return latency of the playback or record pipeline. Flush will throw away all data currently in buffers. Can you not just overwrite it? We'll wait for all send data to finish playing. Don't think I need to do this. All this? But I'm not sure. Connection should be closed and resources freed. Okay. How do you send? PA simple write. Let's try that. Wait, start data. Perfect. So that's slice of view weight, number of bytes, and errors. Start here. Hang on. How do I mention stream sample format? Use the default channel map. How do I specify left and right? What's it called? Interleaving or non-interleaved? PA simple spec. What is that? Sample spec. A sample format and attribute specification. Format rate channels. Okay, this is what I need to know. Simple new stream playback. So you get it? No. Pulse sample pulse error. So it's basically I16. Hey Taras, I saw your updates on Git tool that you're working on. I forget the name. Tux? Mux? Flux? Stacks. There we go, that one. Oh yeah, I forgot. What are you doing here? You should be enjoying your holiday. Well, I guess. Where is the buffer? Where does he write to the buffer? Oh, okay. It's plain file. Okay, let me give it a try. Seems like I don't need that. E.pa simple. Right. This I need. Idea. Server. Buffer and some buffer size. And there's an error. Let's pass it as null. So for that I need the server c.pa simple new. Use the default server. Null. Application name. Yep, playback. Use the default device. Yep. For the game. Sample format. Use the default. Okay, what's... I want to know what are the other channel maps. Stream direction. Playback. Yeah, okay, that's fine. Device. Stream name. Sample. Spec. Format. Rate. Channels. Okay, there we go. I can specify it there. I'll read that's null and null. How can I get the type? I can just get it from here. Sample spec. A sample. Oh, what am I doing? Can I just do dot format is, I don't know yet. Do know channels. And I need rate. U32 sample rate. Sample format. I think this is where I need to specify if it's interleaved or not. If my guess is correct. Let me just format. Connecting. Okay. Oh no, that's the data type. It's PA. Right. Signed 24-bit PCM in least significant bit of 32-bit words. Native Indian. As a native. Okay, that makes better sense. Use PA sample 16. Any. Okay, it's just little Indian. S16. Okay. So that's that. Now I want to know the map. What is this? Connecting. I mean, it's just null here. Transfer in data. Okay, it's the same. Channel maps. Stereo. For stereophonic audio and return a pointer to it. Let me just leave that empty for now and see what happens. A simple read and write. Okay. Some buffer size, sample rate times 1. Yeah, I think that's fine. Or maybe 2. I think this should be, excuse me. I think it should be, wait. That means this would be times size of E16 or I16. Yeah, I'm not sure. Okay, let me write sine wave to it, see what happens. Does this build? Okay, that one's easy. But I didn't want to write to it yet. Or some buffer. Yeah, probably write it after. What's the sine wave thing again? Don't remember. Maybe. I did comment. No, I didn't. No, that isn't. That's fine. I need period size. How to play a sine wave? Should go for half the period, it should be high, then go to low. And then half of that. I also just realized that the largest number can only be like 256, 255. Maybe I can write 16 bits at once. Or maybe no, I don't know. Okay. Sine wave. I need some coffee. I mean, to be fair, that looks about right. Let's give it a go. If make it a U8 equals, I put a small number. I don't want it to be too loud. I guess it doesn't matter if it's negative or positive. No, it does. Why can't I remember that? Alright, let me just go back and check.
Do we hear parameters? And so pretty much the only thing we need to do now is we need to figure out where these guys are going to come from. I believe we caught everything else. I don't know though. There's a pocket for us. So now we just need, we actually need to get that right pointer, and we need to get that byte size right pointer, and we need the bytes to write. Let's see. Okay, so we have to actually get these from somewhere. So that's our next goal. Once we get them, we can then fill the region with a sawtooth, basically. I'm going to do that in a little bit of a sort of janky way here. Again, this is just test code. This is going to get deleted. So basically what I'm going to do is I'm just going to make this 100% explicit. I'm going to say we're going to start writing at a particular sample index, right? And that sample index is, or I should say, yeah, sample index. And that sample index is actually going to be wherever this first region actually ends up being. So yeah. Sorry, I'm not explaining this very well. This is the lack of coffee. Let me say that again. We have a sound buffer, and that sound buffer contains samples. It contains samples that look like this. It contains samples that look like this, right? They're interleaved. And basically each one of these is 16 bits, right? So it looks like this. 16-bit, it's an int16, another int16, another int16, kind of ad infinitum, right? Going on and on and on. So our buffer is 16 bits for the left channel, 16 bits for the right channel, 16 bits for the left channel, 16 bits for the right channel. So basically I want to loop over these things, and this is what we're considering a single sample, because basically they go together, right? We can't output anything less than that. We need to output one of those at a time, because that is the only thing that actually makes sense for our stereo sound. We couldn't output just 8 bits. It'd be like half of the left channel value. That doesn't make any sense. So we're going to output those at a single time. So basically, region 1 size comes back, and it had better be an even multiple of the samples. Because if it's not, something really weird has happened. Because we're only going to ask for an even multiple of the samples. The buffer is only an even multiple of sample size long, and we're not going to ever give it a right pointer that isn't an even multiple. So this would be a good place for an assert. I haven't talked to you about those yet, but we will talk about those maybe in the later of the stream to assert that that's true. Assert that region 1 size is valid, and region 2 size as well, in the case where it gets returned. So we'll talk about that a little bit later. I don't want to start throwing asserts in here until I actually have a chance to sit down and talk with you about what they are. So we'll have to schedule that at some point, because it's pretty important. Anyway, sample index is 0. It goes up to the region 1 size, and then it will be finished. Now, of course, we then have to do the same thing for the next region. So we want to go up to region 2 size, and these sample indices are relative to the region, right? So these are all the samples in region 1. These are all the samples in region 2. And what we have to basically do is we have to fill in something now. So we're going to have to fill in the pointer to the buffer here. Basically, we're going to write two things, a left and a right each time. So the first thing we want to do is get an int16 pointer to the buffer. Now, it returned us the pointer, which was region 1, right? And so this is basically the sample out. This is what we're going to be writing to. So we're going to cast that to an int16, which is the thing we're going to be writing. And basically, we're going to write here. We're gonna write as we increment along. We're going to write our left here and our right here, right? And then we're going to do the same exact thing down here. Does that make sense? Hopefully that's clear. All right. So basically, this will do everything that we want to. We just have to figure out what we're going to do in terms of the actual values here. So what we want to do is we want to go and every sample, depending on which sample we're at, we basically want to go ahead and make a square wave. So we want to be able to basically just do, if our sample index happens to be, the first n samples, it's going to be high positive. It's the first, if it comes after that, the next n samples are going to be low and high and low and high and low. So we're going to use the mod operator for that probably. So basically what we're going to do here is we are going to actually, we don't even really need to use the mod operator. We could be a little more janky than that. So basically what we're going to do is going to find a variable that's going to tell us where we are in our sawtooth pattern. We are basically going to call that, I'm sorry, not our sawtooth, our square wave pattern. We're going to call that our square wave counter. And basically all that's going to do is if the square wave counter happens to be 0, so we're done, it's basically we finished one part of our square wave. If the square wave counter happens to be 0, we are going to set, excuse me, man, I wish I could get healthy again. I can't tell you how frustrating it is to be trying to talk to you and have this stupid cold in my way. It is really annoying. All right. Anyway, this square wave counter is going to basically go up to the number of samples that we want our square wave to have high before it goes low, and vice versa. So basically what we're going to do is we're going to say, well, if our square wave counter, I don't know, I'm going to pick a random value here and then we're going to tune it later, square wave period or something like this. We're going to reset it each time. Again, this is kind of ugly the way I'm doing this. Probably not the best way to do it, but it's the first thing I thought of. So we're going to make it do that way. And then what we're going to do is we're going to say our sample value is just going to be whether or not the square wave counter happened to be above half the square wave period. Basically, that's about it. That's all we're doing. If it happens to be above that, then it will output the highest possible value that it can. Well, maybe not the highest possible value. Let's just say 16,000. Yeah, I don't know how loud we want this thing to be. Basically, this is a 16-bit value, so 32,000 is the maximum it could be. 32, whatever it is, 65536 divided by 2. And if the square wave period, if it's not that, if it's in the other half of the square wave period, it'll output the negative. That's basically all I actually want to do here. And these are basically the exact same loop. So we'll probably compress these in a second down to one loop. But that's basically it. That is all we wanted to do. So all we really need to do now is make sure that we actually fill out all these values somewhat reasonably. I believe that's correct. Okay. Someone on the stream said, let's code a mini Moog synthesizer and emulator instead of a game. You know what? That is Sean Barrett's turf, ladies and gentlemen. I am not the person to do that for you, but I bet if you asked Nothings at Twitter to do a stream where he codes a Moog synthesizer for you, I bet he would do that. That is exactly the kind of thing that he would do, and he is exactly the kind of person who would know how to do that a lot better than I would. I would just end up writing a lot of crappy code like this that I just wrote for you, because honestly, I never synthesize sound really. I always play from some kind of sample materials that get mixed together. So this is way out of my area of expertise, to say the least. But it's definitely the easiest thing for us to write to just get things going. Okay. So we need some stuff here we have not finished, because we have to define some things. Obviously, we have a square wave period, and that square wave period is going to have to be something reasonable. We also have to make sure that we actually decrement our...
Paying attention. Can't remember what he says. Alright, let me just have a look. Basically, we just have to flip sound every half a wave. Okay. Okay. I also realized I made a few mistakes. Because I did specify a 16-bit number. Get rid of that. And this would be an I16. And I think this should be times size of 16. It says bytes. Yeah. And data is any-opaque, so I should be able to just do pointer cast some buffer. Alright, now to actually, so this can be louder. 1000 wave position. I swear I figured this out yesterday. Not sure. Guess that's the same thing. Maybe. Finish the period, just reset it. Oh, sorry, a wave position equals 0. This should be a while. Cause this should be. I need to check that. Basic. Okay, yeah. I less than sound buffer size. And what's the data called again? Sound buffer of I equals audio plus 1. Yep. Sounds like kind of the same thing. I think this should also go to negative. Let's just write that, see what happens. Look. Define symbol, PA symbol. Oh, yeah. What do you mean it's defined? I guess I do need the other one, the other header file. Right, yeah. I'm gonna put the volume down a little bit, just in case. Maybe I put it 5,000 is fine. Okay, that's weird. Yeah. Exported. What's going on here? I did try to build it, just that's weird. You can see it, it's right here. What else is wrong? False, blah blah blah. It's weird. I don't understand that. Right. Let me check with cloud. Why do I get these errors? So I've imported. Linker errors. Can't find. Oh, okay, there we go. Should be simple. Was there any audio? If there was, I didn't hear any. No. That's interesting. Let me go back. What was the problem? LDXE dash L pulse. Transitive failure. Okay, the following build command X failed with exit code 1. Interesting. Does it say anywhere? Okay, interesting. Wonder how you figure that out. If you don't know. Alright, anyway. Okay, there is a bit of a there is a bit of a delay. Let me check the debugger. Oh, I don't check the errors. Good point. Error handling. You configure different login parameters for the PuliseAudio client libraries. Okay, can I just set that? Pulse log equals. Can I do all? Hey, nerd on too. Yeah, trying to. But as of now, I'm just trying to get audio and well, I got window working, so I'm just trying to get audio to work. Okay, let's put that. Okay, that clearly didn't work. PA error code. Convert these values into human readable strings. So is it the error or let's just try. Guessing 0 is not an error. And it debug print audio error. Vanity str error. Looks right. I think I need might have to link the pulse library. No error. Weird. What about this one? Pointer to the int. That's empty too. Okay. Guess I just have to check the debugger. Oh, hang on. There was something else you had to do after writing. Simple API, transferring data. Connection established to the service. Data can start flowing using the connection. Main difference is they call and simple write. Note these operations always block. I guess I could try that. Train, PA simple. Yeah. Just gonna take my headphones off. No. Can I use size of on the slice itself? It's for type only. Never mind. Alright, let me just run the debugger. That is a sound buffer. I mean that does look valid. But that's not it though. Equals 0. Yeah, so just 1000. What does weird? Don't know what's wrong, if anything. Oh, hang on. I did hear something there. Yay. Brilliant. That's exactly what we needed. That does sound like a mid-C. The only question now is... Yeah, okay. So it blocks while it's playing video. I don't want it to block. Synchronous. Can I move this out? Needs ever pointed to see the PA sample. Why is it simple? Let's type again. Struct PA simple. Can move the rest. Silver. Oh, I forgot to call it. Okay. I can check if it works by, let me increase the volume. I mean, it works, but yeah. Here. Double it. Okay, yeah, that is louder. I mean, as great as that is, I'm not sure like if I can use the simple audio, because it can't block when I'm playing audio. His native interface to the Pulse audio library allows full access to all available functionality. This, however, means that it's rather complex and can take some time to fully master. That's a good start. Can I see an example? They only have the simple examples. We'll wait for all sent data to finish playing. I don't know if I should implement the complex one right away. I mean, it doesn't seem too bad. I don't know. For now the audio works, but it's not usable, so I don't know. What I can do is I can try drawing. Redraw. Set and offset. Mm, 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 mm. It's not great. Okay, at least it's much easier to use than what's the other one? Also, I think I might give it a go. I might try to the async API, because at least I have an idea of this, what I want. So okay, I'll count that as a success. I'm happy with that. After like 2 days of struggling with Elsa, I'll commit this. Audio kinda works. Alright, I'll think about the async API tomorrow. I think for now, I'm gonna end it there on a positive note, and I'll decide if I want to do the async API tomorrow. That was kind of fun. Alright, hope you have a good day. I shall see you back here tomorrow, and see ya.